Hello, Mr. Lopriato here. Some video notes on accuracy and precision. All right, two words that we kind of use interchangeably, but they do mean something slightly different. All right, so what we're looking at are 4 targets, all right, and we're trying to compare which one is accurate, which one is precise. So in this first target, we see the shots all over the place, but sometimes it's hit the middle. So we're gonna call that accurate. Now in our next one, none of them are hitting the middle, but they're all clustered together. So we're gonna call that precise. Now in this third target, they're all over the place. So this is neither accurate nor precise, it's neither. And in our last target, all of them are right in the middle. So they're hitting the target and they're in the middle. So we're gonna call that both accurate and precise. So the targets, they kind of make sense if we get by this idea that precision is having multiple repeated units, right? It's repeated and they are close to each other, all right? But we're not throwing darts in chemistry class, all right? We shouldn't be, at least. So we gotta think, well, what does that mean for us in a chemistry class, specifically in a chemistry lab? So for accuracy, accuracy is how close you are to a given measurement. So what we're gonna use for accuracy is something we use called percent error. And we've seen this a little bit in labs. It's the absolute value of an accepted value minus an experimental value that we found divided by the accepted value and then times 100. So this just tells us how close we were to the middle, right? As we get closer to the middle, we're accurate. If we're really far away from the middle, we are not accurate, right? This precise but not accurate, it's not near the middle. Now the precision, how close measurements are, we want to see groupings of measurements that are really close. So if we had 2 sets of measurements, 2.0, 3.0, and 4.0, they're kind of close. All right, but what if we had a second set of measurements and they were 2.0, 2.1, and 1.9, all right? They are closer together. The measurements agree with each other more, so we're gonna call this more precise. And the other thing we wanna say about precision is we get more precise when we get measurements with more significant figures. So what we wanna see, for instance, with the scales, we want to use the analytical scale that gives us 4 decimal places versus some of those other scales that don't give you any decimal places, right? We can get measurements that agree with each other more if we get more significant figures.